Good morning, everyone. I'm Dhanabal Mani, Director of Relay Software Development at Megger USA, Dallas. Today, I'm presenting major breakthrough in relay testing, cloud-based end-to-end testing for line differential relays, line production relays with a novel single-end controlled approach. The new method improves accuracy, saves cost, and eliminates on-site complexity we face nowadays. Let's dive into the presentation. Here is what we will cover today. Problems with the traditional testing and what cloud-based testing is, how the single-end approach works, real-world relay testing using some ABB and SEL relays. Also, what are the benefits this particular methodology brings into the industry? And also, finally, how this saves the future of the production system testing. Relay testing is critical for grid reliability, but traditional methods are slow, expensive, and labor intensive. With the cloud-based test method, we can now test remotely, reduce physical setup, and accurately simulate dynamic faults, making the process scalable and future ready. Let's continue to line differential relays overview. Line differential relays, which say LDRs, isolate faults using Kirchhoff's current law. They compare the current at both ends of the transmission line in real time. Production methods used include the percentage differential and all-pump line methods, both of which enable fast selective fault detection. Here we see how LDRs use synchronized current data to identify internal versus external faults. When the current differential exceeds a certain threshold, production is triggered. This is core line-based production schemes. Let's see what is alpha plan characteristics. Alpha plan is graphical representation of current vectors used to determine the fault types. It is used in modern relays, especially in SEL relays, for fault classification and performance tuning. It's one of the complicated relay functionality to verify because it runs in the imaginary plane. Cloud-based simulation can now model the test characteristics virtually, as well as it can do both end injection and able to test the characteristics. The other one is a traditional differential slope characteristics. In this differential production uses slope setting to distinguish between the internal faults and the CT saturation or external disturbances. Testing these slopes precisely is essential, and the cloud platforms now enable consistent and remote validation by injecting fault currents from the two tested at the same time from the single end. Let's see traditional testing methods, how it works. Traditionally, this testing requires multiple test sets across substations, as shown in this image, precise GPS synchronization, and coordination between multiple operators. It's costly, complex, and limited in handling real-time dynamic testing. So let's see the setup. Here is typical setup. Each relay end requires a test set and a GPS clock. Faults are injected and results are coordinated. Even minor errors can lead to false readings. It's effective but not efficient for today's fast-paced grid. It's going to be a challenging when the situations like COVID, you may not get the skilled employees at both end, worker at the both end, to operate these functionalities. This is one of the scenario it triggered us to come up with this new technology. This end-to-end testing, what this image shows, based on IEEE C37.233 standard. This standard outlines best practices for synchropacer and time synchronized testing. While it provides structure, it does not solve the burden of logistics. Cloud-based testing aligns with IEEE C37 233, but improves practically. Let's continue to cloud-based testing overview. Cloud-based testing syncs two test sets via central server using the internet. Relays can be tested from any location, false signals, synchronization, and results are managed in real time, remotely. This improves scalability and responsiveness. In the future, we can even able to test the 5-terminal line differential testing using this method very effectively. This setup uses single control point, manages the test sets across ends. We do daisy chaining the relay test set using the cloud, which supports synchronized testing without multiple operators. The only requirement is a stable internet connection. Let's see how cloud-based end-to-end testing process works. The process is simple. Configure the test set in the cloud, simulate a fault, relay receives and responds, and data is locked. Test sets can include internal faults, a pre-fault, timing test, and all automated as a test cases. GPS-based IRIG sync ensures the time precision. Remote operation reduces the manual error and labor cost. It increases the flexibility and allows simultaneous multi-scenario execution. If we see the test setup and architecture, this architecture shows how the local and remote test sets communicate through the cloud servers. So this in the cloud, we compare the local and remote and test sets, password, in this case, password and serial number. If both are matches based on the cloud registration, then we connect each other, both test set in the cloud, then local end operator can visibly see both test set in one location and they can able to control it. So you can run the stability, timing, pickup test with no hardware sets, making testing truly scalable. Unlike traditional setup, cloud testing allows the parallel fault injection. Multiple fault types can be simulated simultaneously. This shortens the testing cycles and boosts confidence in relay performance. The way this process works actually, if you see the test set cloud processing, this process compare the both test set username and password, or in this case it's a serial number and password, and both matches. It link the two sets test set in the cloud, and it automatically connect and allow the control from the local to remote, or vice versa. You can able to switch the control. The most importantly, the key requirement is the internet connection here, and we are living in the internet world. It shouldn't be a problem going forward. Let's continue with the cloud-based testing test cases. So in this paper, we did multiple test cases with the line production and line differential production. But we are going to discuss mainly on the line differential production in the presentation. So the two test sets connected at the local and line production relay and remote and line production relay, which is connected using the cloud-based methodology. And you can see here that it's a relay testing software, which is called RTMS. So this is a page source like 6 current and 6 voltage. With a single test set connection, it will show only 3 voltage and 3 current. With the cloud-based connection, it is synchronized both test sets and able to control, able to view, able to read all the 6 current channel at one end actually. So now in traditionally what we do test cases, like for doing the stability test, we inject pre-fault scenario and false scenario, or like for stable and relay operation condition. So how we configure the test cases, like the I1 to I3, V1 to V3 is that is connected to the test set A and relay A, and the I4, I5, I6 is belongs to the remote end test set B, and it is connected to the relay B. So the injection is performed via the time sync. Time sync is the key. The cloud-based technology permits the software to uh, inject the fault uh, more frequently with the synchronized timing. Every 5 second or 10 second, it automatically synchronize the IRIG time and send the right timing to the both test set to inject the fault at the same time. Uh, this also helps to run the dynamic fault testing. What dynamic fault testing in the sense, like without any interruption, we start from one test point to second test point, third test point. So we continuously inject the pre-fault and fault without any interruption of the testing. So this also allows the operator to perform the manual test with manual testing or manual steps without any errors. Actually, this is the one of the biggest advantage with the cloud-based testing. Like normally any traditional end-to-end testing, if you want to run the test, the operator has to communicate and turn on the injection or trigger at the same time. So it's very key there. But in case of cloud-based testing, user no need to perform anything. Once they connected with the connected IRIG signals into the both test set, the cloud-based methodology automatically synchronize it, and it automatically define the test timing, then it run the test. This gives the greater flexibility to the operator to perform end-to-end testing or any manual testing. This also like cut down the cost, and also how it cut down the cost, it increase the efficiency of the testing. So it's improved the test time, and also productivity is increased. So let's see test setup and architecture, how it helps to perform this testing. We have the local PC and the local PC software. In this case, it's RTMS. The same thing like a remote PC, which is connected to the remote test set, and also RTMS software there. The operator will connect the remote end software into the remote mode, and with some password setup. That password is communicated via internet to the cloud. In the cloud, we check the local end password and remote end password, which matches. Then we automatically establish the connection at the local end. Means if you recall the previous slide, we've seen the 6 current, right? 6 voltage. That is exactly, it's done through this process. So this testing method this testing setup allow user to run any type of testing, like stability testing, like you inject both currents at the same time at the local and remote end for the cloud-based testing, and also like timing test you can perform from the one end for the both the local and remote, and also you can do pickup test or like slope test. You can perform any type of testing without any interruption or any coordination between the two operators other than the initial setup. And another important application this particular methodology provides to the industry, like if you want to run the end-to-end testing, normally what we do, like we turn on the test, inject for a few seconds or few minutes, rarely, then we stop it. But some of the applications, some of the test methods across the globe, they want to run for long time the stable condition. This will help user to understand the fiber optic connections, their configurations detail, their wiring, any loose connections. This will give a lot of insights performing in the pre-commissioning stage or commissioning stage to long time injection. Sometimes you can do like a 24/7 injection. That is very much possible because the test sets in this case use the SMRT. Those are like very it can run for a long time. So this methodology, cloud-based technology, allows operator can turn on the injection for a long time, check the stability of the system. And in this particular test case, line differential, we have performed like the pickup test for the local end, pickup test for the remote end. This is not like a one-point testing, like we run, communicate each other, like I'm running the A phase fault, you also run A phase fault. No, not that way it is done. It is a single end operated. It is dynamic and automated testing. User will just click or I click the pickup test for local for all points. Then it simply go run all the testing, and it gives the results at one end. This is another biggest advantage on the cloud-based testing. This allow operator to get the both relay operation test results at one end, and no need to compile like the traditional testing what we perform. We do local end testing and remote end testing individually. Even though it is cloud-based, the test reports are individual. Then after completion of the two tests, one of the operator or engineer need to combine both test results for make sure it matches the requirement. But here, the cloud-based testing provides the operator or engineers both local and remote end test results at one end actually. And also it real-time data it provides, which boosts the accuracy and speed of the feedback actually. This is one of the biggest advantage we have in cloud-based testing. The another challenge industry faces with the alpha plan testing, this is cell 311L or 411L. It's very, very tricky to test this type of relays. Even a single point testing uses the traditional end-to-end testing. But the way this cloud-based testing does, it communicates with the relays, both relays at the same time. The test models are created in such a way it can able to generate the fault and inject the faults dynamically. It does run and it does perform the dynamic search testing using cloud-based method at one end. This all done from the one end operation. If you remember one of the test capability slide, that is what we do from the one end. So this is giving the high-end visibility to the operator what it is happening during the testing. Instead of like we assuming the local end it performs this way, remote end it performs the other way. So in this test, like let's analyze the short test. One of the short tests we analyzed for 3 ABC faults with the local and remote end. In this here, you can see like we injected a pre-fault for around 500 milliseconds, and the fault is applied. The relay is operated, and the fault isolation happened within like a few milliseconds, and the trip output like 87 output extended up to 18 milliseconds in this case. This gives the very good insights why when the testing is performed, the local end PC also can communicate with the local end relay at the same time while test is doing, can monitor or can read the event records actually. This is one of the biggest advantage we have. And also this can allows user to get the data from the local end and remote end relays to compare both the relays. So in this case, like we got the ABC fault type at the local relay, and also like we got the ABC fault from the remote end relay, and it shows the both relays operated and responded for the fault, short set test fault, and it operated and recorded the fault values correctly. In conclusion, or key takeaways on the cloud-based testing, this particular cloud-based technology gives very much control to perform the end-to-end testing via centralized control with the real-time synchronization, and also have the ability to do the dynamic fault injection. It also helps the operator or utilities to allocate the skilled laborers and skilled operators at the specific application. So example, in this case, the utility may not require the same skill level operator to perform the end-to-end testing using cloud-based methodology. And also this technology allows user can perform the testing using testing for line production schemes like PUTT, POTT, or any other carrier-based testing. Also the line differential production schemes. Not only that, this methodology allows uh, doing the scalable operations like multi-terminal testing, like 2 and 3 terminal, 4 terminal, 5 terminal, even 5 terminal testing, which is possible. Uh, and also, this technology is very much in live right now and can able to perform the testing for multiple units. That's the biggest advantage. And also, this technology is a patent technology. It's in the final publication process. I hope this cloud-based methodology help the industry in the future for performing the better end-to-end testing in the fast manner. Thank you.